All right, so for my students who are currently under quarantine, this is going to be a very, very quick run-through of how to work with each of these types of functions, specifically with evaluating. We've done some evaluating before, but that's been more with word problems and some less formal mathematical things. Today, there's no words. There's just f of x, g of x, h of x. There's just actual function rules where we need to take whatever number is given to us in parentheses and plug it in for x. So I'm going to go ahead and do these three for the first section. So for part one, the proportional function f of x equals 5x. If I see f of 0, that means I'm going to start writing this function, but instead of x, I'm going to write 0. So 5 times x becomes 5 times 0, and anything times 0 is just going to equal 0. So 0 is my answer. For the second function, I will do g of 4, where I take the number 4 and I plug it in for x. So instead of 2 times x, it'll become 2 times 4. And then I keep plus 3, so everything in the function stays the same except for the x. By order of operations, please excuse my dear Aunt Sally, multiplication, the m comes before addition, so I need to figure out what I'm multiplying and then what I'm adding. 2 times 4 is 8, and then 8 plus 3 gives me an answer of 11. And then finally, for this last function, h of x equals negative 3x plus 8. Once again, I'm going to take the number it gives me for x and plug it in, so this becomes negative 3 times negative 1 plus 8. So negative 3 times negative 1, if y'all remember your rules about multiplying negative and positive numbers, negative times a negative equals a positive. So this would just be positive 3, because 3 times 1 gives us 3. And then 3 plus 8 is also going to give us 11. So that's 3 examples of linear and proportional functions. Remember, the idea is just take the number it gives you to plug in and plug it in for x. Everything else stays the same. The 5 stayed the same in this one. The 2 times and the plus 3 stayed the same here. And the negative 3 times and the plus 8 stayed the same for this one. So next, I'll do 2 each for the quadratics and the exponentials. For the quadratics, I'm going to go ahead and do the negative 1 for each of these, because I do want to emphasize this idea about squaring a negative number and cubing a negative number. So I'm going to take negative 1, and I'm going to plug it in for my x. I'm going to put parentheses around it if I have an exponent, because that's a really good thing to remember to do. It's going to help with the actual process of squaring in or remembering what that is. I still write my squared in plus 1 normally. So now that I have negative 1 squared, this is the same thing as negative 1 times itself. Negative 1 times negative 1 would just give us positive 1, because a negative number times a negative number is a positive number. So positive 1 plus another 1 gives me an answer of 2. So f of negative 1 equals 2 here. And then over here, when we cube it, this is where it gets a little trickier. Like I said, I need to start by writing negative 1 in parentheses and putting that exponent of 3 right above it, tacking the plus 1 onto the end. And now that I know that I'm multiplying this number by itself 3 times, negative 1 times negative 1 times negative 1, I can start by multiplying my numbers. 1 times 1 times 1 is just 1. But I also need to look at my negative signs. And basically, any pair of negative signs will cancel each other out. So negative and negative go away. This is like multiplying positive 1 times positive 1. So now, if I just have positive numbers and one negative number, I know that that is going to give me a negative answer. And y'all are welcome to try this in your calculators if you would like to. So this is negative 1. I still need my plus 1 on the end, and this expression comes out for an answer of 0. So again, I just wanted to do these two to emphasize both the process and the importance of keeping track of your negative signs with this kind of problem. So finally, for the exponential, I'm going to go ahead and do the middle one. Actually, no, I will do the first two in this first example, because I want to emphasize the importance of remembering what it means to raise something to the 0 power. So once again, I'm going to start by writing everything else in the function except for the variable exactly as it was. But instead of my x now, I'm going to put in 0. This type of problem, this type of function is different from the others. We had the variable in the base here, and the exponent was just a number. But now we have a number in the base, and the exponent is our variable. So this is going to change just a little bit. So 2 times 3 to the 0 power. And the one thing that I want y'all to remember that I wrote on everybody's sheet is that anything to the 0 power equals 1. So 2 times 3 to the 0 becomes 2 times 1, which would produce an output of 2. Now for this f of 2 over here, I'll do this one, and then the middle one here, g of 3. F of 2, I'm going to start by writing everything else in the function except the variable the exact same way, 2 times 3. I plug the 2 in up top. So now I need to find 3 to the 2nd power, or 3 squared, which is 9. I am still multiplying that by 2. 2 times 9 gives me 18. And finally, for g of 3, the last one I'll do in this video, I'm going to start by taking everything in this function and writing it just as I found it, 9 times 2 to the something power. And in this case, that is 9 times 2 to the 3rd power. Now, y'all might see 3 to the 2nd power, 2 to the 3rd power, and think they're the same thing. They are not. For 2 to the 3rd power, this is the same thing as 2 times 2 times 2. 2 times 2 is 4. 4 times 2 will give me 8. So 9 times 2 to the 3rd becomes 9 times 8, and 9 times 8 gives us an answer of 72. I'll run back through this once again, just so you can see all the answers that I wrote. The rest of these are y'all's responsibility. Good luck.